I see it come up. Yeah. Should be streaming now and everything's online. Good morning, everybody. My name is Jack Broadbent, and we're going to start this compost webinar in a few seconds. Let me do a sound check with Frank. Frank, are we on and everything good?
All good.
Perfect. All right, excellent. Welcome, everybody. This is pretty exciting for us to get this started. It's a combination of efforts, and I want to just welcome all of you to our first day of the webinar for improving roadside revegetation and stormwater quality with compost-based BMPs. It's an enormous team effort. We started this where we were going to do face-to-face workshops, and then of course in March, you all know what happened. So we shifted over to online. So we've been working hard behind the scenes to get to this moment in today's time. So hopefully all this works well. Hopefully you guys learn a lot out of the workshop. We put together an incredible panel of presenters today. And I just want to say welcome and thank you. What I do want to really reach out and say thank you, a special thank you to Frank Shelley and Sharon Rosen and others that are behind the scene to help make sure this new virtual environment works for us. It's an amazing Caltrans team we've got behind us, and also an amazing group of people that are supporting us from industry and also from Cal Recycle. So with that, I want to say thank you to Brian Larimore from Cal Recycle. We've created a partnership between the two agencies, and been moving forward with this compost workshop and a lot of other partnerships. We have worked together for over 2 decades, trying to increase the use of recycled materials, such as recycled concrete, recycled glass, plastics, tires, and of course today is all about green waste, which is compost. The partnership with Cal Recycle and industry has led to fantastic innovations, new products, new markets, and an increased use of recycled materials. For example, Caltrans uses rubberized asphalt concrete to pave our roads. That gets rid of the tires out of the waste industry. We've invented and worked with industry to put down rubber vegetation control mats, which are 100% recycled tire. We've used plastic lumber in our Caltrans systems, used crushed recycled glass to cover our landscapes, and now we're using a tremendous amount of compost, which helps keep the green waste out of the landfills. I want to thank all the speakers today. We've got an incredible lineup for you. From Caltrans headquarters, which is here in Sacramento, our districts, which cover the entire state of California. We've got help from the erosion control industry, universities, and the composting industry. These speakers are national experts in the composting and the use of compost in erosion control, sediment, and stormwater control treatments. I want to thank Neil Edgar, Dr. David Crone, Dr. Britt Fawcett, Michael Farrar, Matt Cotton, Jim Phillip, John McCullough, Scott Dallin, Jeff Peterzak, and Dr. Sally Brown. They're all presenting for you during this workshop. Ron Alexander will be managing our question and answer period. So thank you all for joining us. And I want to cover a little bit of how today's going to go. We've got a lineup of experts. Mainly today is going to be more of the compost production, the legislation, the legal requirements behind the compost industry, and the standard specifications that we have at Caltrans. Tomorrow, you will be listening from experts that are managing and working in the applied application of compost. And you'll see some very exciting applications of compost across basically throughout the world. So you can see how all that functions. My name is Jack Broadbent. I'm a senior, not a senior, I'm a supervising landscape architect here at Caltrans. I've been at Caltrans for about 33 years, and I'll be your overall facilitator. We have two different timekeepers, Scott Dallin from our District 5 Landscape Architecture Office, and Mike Farrar from our headquarters Landscape Architecture Office will be keeping time. Brian Larimore from the Cal Recycle will be introducing each speaker as we come up, and then Ron Alexander will be managing the questions. So if you have questions during the workshops, up on the screen, we post the compost workshop at dot.ca.gov. Send your questions into that email box. I've got 3 or 4 people behind the scenes pulling emails up and feeding those questions to Ron Alexander. So with that, I'd like to go ahead and start the workshop. And I think, yeah. Let me just double check or double back a little bit. On the second day, at the last part of the day, we'll have all the questions pulled together, hopefully, and then we will have a panel discussion with all of the presenters. Ron will be hosting that panel discussion and trying to cover most of your questions. If we probably won't be able to get to all the questions, and what we will do is collect those, do a question and answer process, and then repost that up onto our Caltrans Division of Design Landscape Architecture website on the external website. It'll take probably a week before we get that posted. But we can also send to the participants that were able to get registered, we can send that out to all of you via email. So with that, let's go ahead, and Brian, if you'd like to introduce our first speaker.
Thank you, Jack. Before we get into the presentations, I want to add my thanks to the hosting team, the speakers, the panelists, and the Caltrans IT staff. A lot of work went into developing and bringing these workshops to you, so thank you very much. Our first speaker, Neil Edgar, is a senior project manager with Edgar & Associates in Sacramento, California. Neil is also executive director and co-founder of the California Compost Coalition, a statewide lobbying coalition that focuses on legislative and regulatory development regarding composting and other organics management options. Neil is a member of the United States Composting Council's Legislative and Environmental Affairs Committee and serves as a policy liaison to the California Organics Recycling Council, a statewide advocacy group dedicated to increasing the sustainable use of recycled organics. Neil will discuss workshop goals and relevant legislation. Neil?
Thanks, Brian, and thank you very much to Jack and the Caltrans team. And I also want to thank Brian and Cal Recycle, and in particular, I recognize that I believe this is Brian's last hurrah. He's officially retired as of the end of this workshop. So appreciate the nearly 2 decades of work that I've done with Brian, and the impact that he's made on helping to grow markets for recycled materials. Next. So I've been drafted to give us an outline of the workshop goals. We're here to provide education on how to enhance roadside project sites with the use of compost for native plant establishment and revegetation, slope stabilization, erosion control, and erosion and sediment control, and improved stormwater quality. And you'll hear a number of success stories over the next 2 days. A lot of these uses have been well established over 2 decades, 3 decades, implemented by a number of departments of transportation, including the very progressive state of Texas, where they've done similar types of workshops dating back nearly 25 years. We're hoping to increase the use of compost and comply with the requirements of AB 2411, which is recent legislation I'll talk a little bit more about. We're here to help further the achievement of our state climate change goals in SB 1383 by growing compost markets, including fire remediation and municipal procurement. I believe taking action on climate change policies, reducing methane from landfills in this case, needs to be a priority for all of us and certainly all public agencies in California. And lastly, we're here to provide a forum to discuss opportunities and barriers to increasing compost along roadsides. So for some of you, this process and these projects are fairly new, these new applications of compost. It may be new to the specifications, but in California, our landmark legislation for recycling, AB 939, was passed in 1989. And as a companion bill, one of many companion bills that were passed over time to help augment market development for the recycled recovered materials under AB 939, among them was SB 1322, a Bergeson bill passed the same year that required Caltrans to use compost in place of or supplement petroleum-based commercial fertilizers in the state's highway landscape maintenance program. More recently, SB 1383, our short-lived climate pollutant bill, has tasked CalRecycle with spearheading a paradigm shift in organic waste management here in California. We are looking to reduce methane emissions from landfills by diverting 75% of organic materials from landfill by 2025, leading to predicting about a 10 million ton increase in the amount of finished compost and other organic products that will be developed. Recently, SB 1 was passed, another landmark piece of legislation here that authorizes the expenditure of billions of dollars in roadway improvements. Among the measures in the bill, it requires CalRecycle to use advanced technologies and material recycling techniques that will reduce cost and also exhibit reduced levels of greenhouse gas emissions through material choice and construction method. Important elements in developing sustainable programs here in California. AB 2411 passed 2 years ago and has matriculated this workshop effort and a renewed effort between Caltrans, CalRecycle, adding in the Department of Parks and Recreation, Department of General Services, and CAL FIRE, directing CalRecycle and CAL FIRE and Caltrans to change practices and identify the use of compost. It directs DGS and CalRecycle to maintain specifications for the purchase of compost in the state, which are Caltrans has had in place for several years, but this will extend out to other state agencies. And it directs the Parks and Rec Department to initiate programs to restore public lands that use compost, co-compost, rice straw, etc. Compost usage has had a little bit of a roller coaster ride. You can see that it expanded pretty significantly from 2009 to generally to 2016, with a little bit of a lull the last couple of years. The latest information here shows Caltrans using about 130,000 cubic yards of compost on roadway projects and landscape maintenance projects. My one takeaway is that we need to help build markets for the additional compost and mulch products that are going to be recovered under SB 1383 programs. And we're going to need everybody's help in developing those markets, including Caltrans and Department of General Services, Parks and Rec, and every agency in the state to help move materials to sustainable uses. and I am happy to answer any questions.
Okay, thanks, Neil. This is Ron. I'm waiting to see if any questions have come up. There were a couple questions, Neil, that were asked before you started speaking, but they are not related to your presentation. So I think I'm going to hold them off unless you want to talk about bacterial contents of the use of compost in your water bodies.
I don't want to jump ahead of the next speakers who are going to provide some of that same information. So I will let that question stand.
Right. Waiting to see any other questions. Neil, I do have a question. Are you familiar with, as far as Caltrans usage goes, is there one area of the state which is more popular with the Caltrans engineers? Do you know?
I don't know. I do know that out of the 12 districts in the state, that there are a couple of districts that have done an outstanding job of moving materials into projects. My understanding is that the Central Coast is particularly robust, and also up in the Sierras around the Lake Tahoe region, which are two of the more sensitive watersheds in the state, and yet they've had a pretty successful implementation over several years.
That's fantastic. Okay, no other questions have come in, so thank you, Neil, and I'll pass it on to Brian.
Thank you, Ron. Our next speaker is Dr. David Crone. He earned his PhD in 1992 from Cornell University, where he concentrated on soil and water engineering, water resource systems engineering, and biogeochemistry. Since then, he has been working as a professor and cooperative extension specialist at the University of California, Riverside, where his research has emphasized beneficial uses for organic residues as compost, fertilizers, and mulches. David will discuss composting processes and the characteristics and uses of compost, mulches, soil amendments, and organic fertilizers, including the use of compost to improve post-fire water quality. David?
Thank you very much. It's great to be here. Next slide. So many of you have probably done some backyard composting. It's the same idea, except for we're going to be going big scale. Next slide. Next slide. There we go. Okay, so when we talk about composting commercially, we're looking at systems like this. We're talking about what's called thermophilic composting, which means it's happening at hot temperatures. The hot temperatures move the reactions along, and we depend on those temperatures to create a lot of the benefits that we get from compost, which I'll be talking about in just a minute. Next slide. Okay, so composting is an aerobic process. Aerobic means it requires oxygen. So I want you to look at yourself when you think about composting. You probably had breakfast this morning, or you should have. You're sitting in your chair, you're breathing. As you breathe, what you're doing is you're taking oxygen, combining it with carbon to liberate energy. And you're giving off carbon dioxide as you breathe out. You're giving off water, that water you see in the mirror when you breathe on it in the morning. Some of that is water you drank, but a lot of it is water created by the decomposition of your food. That happens in a compost pile as well. Back, not done yet. Back up, no? All right, we'll move on. So when we talk about thermophilic composting, we want to keep in mind that microbes tend to specialize in
Dave,
temperatures.
this is Jack Broadbent. Let me interrupt real quick.
Yeah.
There is and to all of you listening, there's about a 30-second, maybe even a 45-second delay between the slides advancing and them posted out onto YouTube Live. So it's going to be a little challenge, Dave, for you to keep track of the presentation while I'm trying to move the slides so that that delay is seamless.
Okay.
All right. So that's
Awesome.
why the slides are jumping on us. Sorry about that. Technology
right.
is a challenge for all of us in this time.
Okay. When we talk about thermophilic composting, you need to keep it, that refers to the heat in the compost pile. Microbes that are thermophiles prefer hot temperatures. Mesophiles prefer the sort of ambient temperatures that are present in the environment and in our bodies. Pathogens are mesophiles. So between 110 degrees Fahrenheit and 155 degrees Fahrenheit, thermophiles dominate. But above 160 degrees, you can actually get a pile that's too hot, and the microbes in the pile can die off. But the benefit of these one benefit of these hot temperatures is that you get reliable pathogen kill above 131 degrees Fahrenheit. Another benefit of the heat is that it greatly accelerates how fast microbes work. Next slide. Great. So if you're a composter and you're in compost business, you don't make money by having a bunch of material on your site. You make money by bringing in feedstock and moving it off as cured compost. Heat, as I said, accelerates how fast microbes work. For every 18-degree increase in temperature, microbial efficiency approximately doubles. So the question is, how much faster will organic matter decompose if it heats from a shady 72 degrees Fahrenheit to 150 degrees Fahrenheit, as you would find in a compost pile? Next. The answer is 25 times faster. So you can process it 25 times faster. That's a big deal. Next slide. So why compost? Next slide. Or next. There we go. We compost for a variety of reasons. We want to eliminate disease organisms. Sanitation is important. We can eliminate animal diseases, human diseases, but also plant diseases. We're taking these materials, we're applying them to plants. We don't want to be transmitting diseases. We also produce a nice, stable, and safe soil amendment, one that's going to release nutrients rather than tie them up, and one that's going to be free of objectionable odors and free of phytotoxins. During the compost process, as materials break down, they can go through forms that are actually toxic to plants, phytotoxins. So you want to make sure it's nice and stable and those phytotoxins have been thoroughly decomposed before you apply it. Composting takes care of all of these issues. Next slide. It takes care of it in two phases. In the active phase, that's when the pile is crazy hot and the microbes are getting everything they want, everything they need to thrive and reproduce. And so it's an enormous party in the pile, an enormous party where they're grabbing a bit of the food and partially decomposing it and throwing it over their shoulders and grabbing another one and eating it a little bit. And those nibbled materials can be toxic to plants and they can contain odors. So during the party, it's a big mess. It's chaos. Eventually, though, the food gets eaten up to a point where it's less interesting. And what happens at the end of, what happens in a party when you start to run out of food? Well, the party dies down, people leave, there's less activity, right? And what's left over is it's a mess and you have to clean it up. And you clean it up through curing. So a composter manages the material very carefully. During the active phase, it's hot, there's a lot of action, a lot of activity. During the curing phase, the pile is just kind of left to sit. And microbes clean up partially decomposed materials that may have odors, that may be phytotoxic, until the material is nice and stable and ready for use. And that's called curing. So you want a well-cured material, free of odors, objectionable odors, before you use it. Next slide. Compost, of course, has some odors. We call those odors good and appealing when it's a good material. So composting is a biosecurity measure for plants, for animals, and for humans. Next slide. All right, so we're going to circle back through what we just talked about and go into more detail now. A composter is manipulating a variety of components in order to achieve optimal results, optimal conditions for the microbes. Carbon is the source of energy for the microbes, just as it's our source of energy. And the composter will deliberately provide that to the microbes in the compost product through the feedstock. But not all forms are equally available. And you know this, right? You know, your sugars are more available than anything in your own diet. You've got fats and proteins and maybe waxes that you also have in your diet. You can break those down. Microbes can also break down cellulose, and which is the stuff you find in wood chips, right? And lignin, which is an even more recalcitrant or difficult to decompose material that you also find in wood. So if you have a material that's got a lot of cellulose and a lot of lignin, it's going to break down more slowly out in the environment. And sugars, fats, waxes, proteins are going to break down mostly in the composting process itself. Next slide. But you have to have the carbon there to provide the microbes food. In this slide, you see hay and you see something that looks like manure. The hay is the great source of carbon here. That's mostly carbon. Next slide. And composters will mix those together to get a good balance of carbon, the food source, and nitrogen, which is the most vital nutrient for the microbes. And they use the nitrogen to create the protein they need to grow and reproduce, as well as the genetic material that they use to reproduce. Now, if there's too much nitrogen in a pile, you can get excess ammonia emissions, which are associated with air pollution and have an odor. Some other nitrogenous compounds can be odoriferous that are associated with proteins. They have colorful names like putrescine, cadaverine, smells like dead rotting bodies. But so you don't want excess amounts of nitrogen in the pile. You want enough to support the microbial growth and development. And you also want that material to be present because once you use the compost, it is plant available. It's an important plant nutrient. So what a composter does is they blend carbon and nitrogen in the pile to get a characteristic ratio around 35:1. It can vary a bit, but around 35:1. And during the compost process, the carbon goes off as carbon dioxide. Nitrogen tends to be recycled in the pile. So during the compost process, that carbon to nitrogen ratio drops so that when you get a final product, it's usually somewhere between 10 and 20:1 in the final cured product. Next slide. So in this slide, we've got beautiful watermelons, but the nitrogen is actually in the brown stuff, in the manure. The watermelons, which I just like this slide because it's pretty, although I think it's a tragedy that we're composting such beautiful fruit, but I guess it was overripe. Anyway, that's full of sugars, which is full of carbon. So the brown stuff is the nitrogen. Next slide. Oxygen. Why do you breathe? You all know that you need to breathe. You're breathing all of the time. If you don't breathe, you feel really uncomfortable pretty quickly. But why do we do it? We do it because oxygen, O2 oxygen, acts as an electron acceptor. As we break down our food, a chemical reaction occurs and we release energy. But the amount of energy is determined quite significantly by where we put electrons that are being transferred within the reaction. And if we transfer those electrons to oxygen, we can release a lot of energy. It's really, really, really efficient. Okay, so same in a compost pile. You can have a compost pile without any oxygen, and it will break down, but it'll break down really slowly. You're not going to get the heat that you need to inactivate pathogens and other things, and you're going to have odor problems. So the most important thing in managing a pile so that you don't have odor problems and you have rapid processing is to make sure that oxygen is available to those microbes. So a lot of what we do in managing a compost pile is getting the oxygen to those microbes, and that releases the energy that they need to grow and reproduce. Next slide. So you saw this slide earlier. This is called a turned windrow. Next. Why do you turn a pile? Now, most people think you turn a pile because you're stirring in oxygen somehow. You're mixing oxygen in. There's a huge amount of activity in these piles. The oxygen that you get into the pile when you turn it is probably gone within just a few minutes. It gets depleted because there's so much activity in the pile. It gets consumed right away. But a turned windrow is a really beautifully designed heat engine for restoring oxygen into a pile. What happens is, in the middle of a pile, you have heat. Because compost, it turns out, is a great insulator. If you ever put your hand into a large pile, you can feel it gets hot right away, and it holds that heat. So the gases, as they're given off by the microbes, that carbon dioxide, it expands and rises out of the pile like a hot air balloon. But nature abhors a vacuum, right? You've heard that. So what happens is that creates a draft. And as the used air leaves through the surface of the pile, it creates a draft that brings in fresh air from the sides. And so you get this cycle of restoration of oxygen. So why do you turn the pile? Over time, the pile particles condense, the pile collapses, and the pores that the oxygen moves through get interrupted. So the reason you turn the pile is to fluff it up and restore those air passages so that oxygen can move through into the pile, and used air can actually move out of the pile. So you're fluffing it up. That's why you turn the pile. Next slide. Water. Okay, water is critical too. Water is where the microbes live. They live in a bath on the surface of particles. The water clings to the compost particles really well. Microbes live in that bath, and they can't live without it, really. They can't reproduce without that water bath. They live in the water. But if there's too much water, it fills up the pores in the pile, and then oxygen can't get in. So composters need to make sure there's enough water for microbes to have a place to live and grow, but not too much so that they don't fill up the pores, so that it goes what's called anaerobic, or without oxygen. Next slide. So here's a picture of compost particles, and there are passages between the particles through which air moves. And inside the particles, there's not a lot of air, but that's where the food is. Outside the particles, that's where the air is. So the microbes are living on these thin films of water surrounding the particles. They get their oxygen from outside the particle. They get their food from inside the particle. And you can see if there's too much water, those pores that the air is moving through are going to get filled up, and the microbes won't have the oxygen that they need. It goes anaerobic, and that's when you get the odor issues. Next slide. We have three broad categories of compost technologies. Okay, we just talked about turned windrow. That's the majority of our systems. Turning windrow systems are very efficient, but they do require a certain amount of land. And so we're seeing an increase in the amount of static piles because those can be built a little bit closer to residential areas, for example, or places where people are around. In a static pile system, you're actually forcing air through the system mechanically, rather than just turning it and allowing that passive heat engine to take place. Those are becoming increasingly popular. In-vessel systems, you can do composting indoors. And if you do it indoors, it's an in-vessel system. Those are nice for engineers because you can capture the gases coming out of the pile, you can treat them, but they are much more expensive than the other alternatives. Next slide. All right, so you're a composter, you've got your technology. What are you managing? Particle size. If it's, you want a size that's big enough to create those pores, but not so big that the microbes can't eat it in time for market. So if the particles are too big, it's really hard to consume the inside. They're too small, the particles get too small, and the air can't get through as well. Particle size is directly related to porosity, and contribute to porosity, and so does turning. You're increasing those pores so that air can move through. The carbon to nitrogen ratio is the balance of nutrients to the food source, food supply. Water is where the microbes live. They need that home. If there isn't enough, they won't have it. If there's too much water, it fills up the pores and they don't get enough oxygen. And then oxygen is that electron acceptor that they need, basically, to breathe. Next slide. All right. Soil improvement using compost. So let's talk about how you use compost to benefit soils. Next slide. Okay, so here's a picture of a food web in a soil. We have microbes in the soil. What are they eating? They're eating plant parts that are decomposing. They're decomposing those plant parts, and they're relying on the plants above them for their food supply. So it's in the interest of a microbe to develop a soil that promotes plant production, because that's what they're depending on for their food. So it's not a coincidence that microbes actively improve soils so that plants do better. And then all the other animals in the soils and on the soils then eat both the plants, and they actually eat the microbes that are decomposing the plants in the soil in this trophic network through bacteria, fungi, nematodes, all the way up insects to animals. So this is the foundation of our ecology. Next slide. So how do they transform the soils? What gives them their superpowers? Well, if you have a soil that's sandy and doesn't hold soil, compost will help it to stick together, hold water, I'm sorry. Compost will help it to stick together so it can hold water. If you have a clay soil that's really heavy and you can't get air in it, you can't get water through it, compost will stick those clay particles together so that they will aggregate. And those aggregates behave very differently. And we'll talk about that in a second. How do they aggregate the soil? They aggregate it because they have hypha. Fungi have hypha that tie the soil together. And bacteria actually exude glue that kind of sticks those soil particles together. And together, the fungi and the bacteria create these aggregates, and an aggregated soil is said to have good structure. So when you hold it in your hand and you see it, you can kind of roll it around. It's got a good structure, or sometimes we call that tilth. An aggregated soil holds water, but it also allows air to penetrate because roots need air. It facilitates drainage, so you can get water. Water doesn't just pond on an aggregated soil, it moves through. And if you have salts that you need to remove, that facilitates salt removal. It allows roots to penetrate. And aggregated soils are also more stable, so they don't erode as quickly. Next slide. So we apply soil amendments. What's a soil amendment? A soil amendment is a material you're mixing into the soil, not on the soil, into the soil. And it aggregates the soil when it's compost, and that improves tilth. It improves water holding capacity. You can hold more water now. It improves aeration. Roots need oxygen. It improves infiltration capacity. If you have a soil that's acid or neutral, using compost it doesn't move it a lot, but it will tend to move it toward neutral. And most plants like a neutral pH. You can buy specialty compost if you want an acid-loving plant, if you're growing acid-loving plants, or alkaline, if you want an alkaline environment. It also promotes microbial activity and diversity, and that robust microbial environment can help to suppress certain diseases. Next slide. So you're mixing in the compost, you want to aggregate it. Keep in mind that these changes take time. You're applying typically in an agricultural environment, not nearly enough to see an immediate change in the soil structure after you put in the compost. because it's not the compost particles being introduced to the soil that's changing the soil. Remember, it's the microbes breaking down the compost, the fungi sending out their hyphae, the bacteria gluing the soil particles together that's forming these aggregates that's enriching the soil. So it takes a bit of time. It can take a few years, and it takes repeated dedication, but you do see improvements. In the laboratory, interestingly, it takes us longer than in the field. If you ask farmers how long it takes, typically they'll say like 3 or 4 years. In the laboratory, it can take longer when we're applying at the agronomic rates that are typical of agriculture. If you're in a horticultural operation where you can apply a lot more compost affordably, you can create changes much more rapidly. But when you're picking a soil amendment that you're mixing into the soil, you want it to be mature. You don't want it to have an off odor. If it has an off odor, that's an indication that it's not fully mature, and it may have phytotoxic compounds still present. And those are poisonous to plants. How do I know if the odor is bad? Is it rank, right? You have a nose to tell you if something is good to eat or not. If it smells spoiled or rotten, challenge it and say, is this really mature? It should have an earthy smell. It has a smell, but it's not an objectionable smell that makes you crinkle your nose. It's one that says, this is soil, or this is going to be healthy for a soil. There are also measures that you'll be learning about later this afternoon to indicate whether a material is mature. So we can actually measure this in a laboratory as well. If you're choosing a soil amendment and salts are a concern in your area, some composts have more salts than others. Now, a lot of those salts tend to be associated with nutrients. The most nutritious composts show a lot of salts in their numbers because ammonium, nitrate, most of the most important fertilizers are also salts. But it's something to keep in mind. That said, I have treated saline sodic soils with compost, totally destroyed soils with compost and remediated them instead of using gypsum and had really great results. Next slide. Mulches. A mulch is anything covering the soil. You can use compost as mulches, and there they'll protect the soil against erosion. They intercept the rain particles as they fall in the soil and encourage infiltration. Mulches also conserve water because they allow the water to get into the soil rather than evaporating from the surface of plants. They control weeds by shading them, basically, and they can help control certain plant diseases, and they're attractive. Next slide. So when you're choosing a mulch, what kind of compost do you want? You typically want one with a higher carbon to nitrogen ratio because you're not interested in them breaking down to encourage microbial development and transformation of the soil. The reason you're applying them is to have something that's going to persist on the soil surface as a physical barrier against weeds and as a physical barrier against the energy of rain falling on the soil surface. So you also want larger particle sizes. If they're too small, what happens? You're basically creating a bed for weeds to grow in. You're also going to hold water up above the soil, and where are the roots? They're down in the soil. So you can actually lose water if you use composts that are with particles that are too small. You want larger particle sizes. You want low trash levels because that's where you see them, is on the soil surface. Maturity is less important. Phytotoxicity, you're above the root zone, so it's probably a little bit less important on the soil surface. Next slide. Nope, we lost it. Okay. Organic fertilizers. All right. Composts contain nutrients. They contain nitrogen, phosphorus, potassium. They're a great source of micronutrients. But they're not typically marketed as fertilizers because the rate at which the fertilizers are released is hard to predict. It depends on the environment. It depends on the precise characteristics of the material. So when you're using organic fertilizers, it's important to next slide. It's important to conceptualize them as a long-term source and to account for them in long-term nutrient budgeting, but to keep in mind that it's not available immediately. So if you're growing corn and you need all of that nutrient release all at once, you're probably going to need to supplement. But if you're growing plants that need nutrients, a lot of landscape plants that take it up gradually over time, it may be all you need. It may take a few years for the compost to supply those materials continually, but they will be an important source over time. So you may need to supplement at the beginning. Low carbon to nitrogen ratios are better fertilizers because they just contain more nitrogen. Next slide. All right, I was also asked to talk about some work that we did on using compost to remediate soils after wildfires. Next slide. So this is an example of compost use. And it turns out compost applied to soil surfaces controls erosion better than anything that I've seen. You can put in structures, like here's K-rail. But what that does is it concentrates flows and the water will flow around and create gullies. There's the slope you can see on the left. Those are two slopes right next to each other. One has straw wattles and a bunch of other things, and you can see they really did nothing. Exact same location with compost applied. Tremendous erosion control. Why? Because the water hits the compost, moves under the compost, and infiltrates rather than running along the surface and concentrating and carrying soil particles away. Next slide. So to study this, and the question is, of course, if you're applying compost, maybe we're adding pollutants that are then exported. So we did a controlled burn, and this is the firefighting crew. You can see my two boys there were helping out, and we did a controlled burn at the University of California, Riverside. Next slide. And we installed a bunch of plots. We looked at conventional composts. We had fines or fine textured compost. We had biosolids fines. We had green waste compost, fines and overs. Fines are the small particles, overs are the large particles. And we applied them at 1 inch, 2 inches, and then we had 2 inches of materials that was incorporated, and we had a control. And we had these plots, and they all were collected. The runoff was collected in bins and then analyzed. We had 4 storms. 3 of them were huge, and that was 75% of the rain that fell that year. Next slide. All right, so what did we see? This slide shows runoff depth, which is the volume of water running off the plots. And this is the most important factor, I think, in our results. When you look at the control on the left, you see we had much more runoff from the controls than from any of the treatments. Green waste compost, 1 inch, green waste compost, 2 inch, green waste compost incorporated. And then green waste fines, those are the small particles, 1 inch, 2 inch incorporated. Then we had biosolids, 1 inch, 2 inch incorporated. Next
David,
slide.
we're at the 5-minute mark.
Thank you. Oh, I have 10 here, but okay. Go ahead. I'll be wrapping it up right now. Okay, so when you look at this is suspended solids. We looked at a bunch of constituents. Compare the suspended solids in the control versus all of the treatment exported. So we had less constituents coming off the plots as a concentration, but when you weight them by the flow rate to look at the total mass that was exported, it was a tremendous difference. Next slide. Compost blankets reduced runoff by 86%, dissolved solids by 88%, suspended solids by 96%, total solids by 97%, phosphorus by 72%, orthophosphate 77%, suspended phosphorus 98%, and nitrate by 73%. we found that surface mulching and incorporation performed similarly. So we could actually incorporate it and it still worked. We also found that less was a little bit better because with some of the things like biosolids, we were actually introducing things like phosphorus, but we weren't getting additional benefits. So it was better to go with less rather than more. And we didn't really see much difference between ogres and fines as far as pollutant export, which was interesting. Next slide. So in summary, composting stabilizes organics so that plant and human diseases are eliminated and weeds are reduced. It's a biosecurity measure. Composts inspire microbes to improve soil structure so that they hold and transmit water better, that they retain nutrients, and plants thrive. Compost mulches can control erosion that follow fires. And I am ready for questions.
Okay, David, that was wonderful. We have a series of questions here, and we have about 7 or 8 minutes to go through them. David, you were just talking about how composting is a biosecurity measure, and one of the questions was asked that on times there are communities that mulch tree trimmings, and they're given away or sold as mulches. Is there a concern in the introduction of invasive species or noxious species of weeds along the roadside?
Well, if you're chipping up wood from trees, weeds are less of an issue. But there are plants, tree diseases. There are invasive insects, for example, like shot-hole borer. And in the case of citrus, Asian citrus psyllid that can be around in the area of trees that are chipped up. And those can potentially transmit the disease. For example, Asian citrus psyllid in my area, citrus disease, we see it happening along roadsides where plant materials are being transported along the freeways. The shot-hole borer is another regional disease that affects all kinds of trees, including sycamores. And those organisms can survive in wood chips, potentially. So what you don't want to do is take those materials and move them to a place where they can actually take hold. So yeah, there is a risk, but it's a really difficult thing to study and characterize.
Yeah, fair enough. Fair enough. There was a question asked, can human waste be used for composting? Is there research in the industry done on human waste composting? I only assume that they mean biosolids. Yeah,
human waste, after it's treated, is used all the time for compost, and it has been forever. There are hundreds, I'm sure thousands of papers on it. It is it's widely done. It performs very, very well. The only main disadvantage in using biosolids is if you use biosolids compost, you can't go certified organic. It's not permitted. But as far as performance and how well your plants are going to like it, it's absolutely great.
Yep. Actually goes back to the late 70s. Okay. Well, one other question here dealing with, and you talked a little bit about it with your fire study, but what are the inherent safety issues as far as using compost blankets as permanent erosion control if you're using it around water bodies?
Okay. If you're using it around water bodies, it's relative to your the background environment. So you're going to be improving conditions as far as infiltration goes. So you're going to have less runoff into the water body. Now, I can only extrapolate. Where I live, we don't have a lot of water bodies. So I can only extrapolate from our results. And what we found was that the mass loadings from our area, and in other areas, we're replicating this right now, were significantly less when we use the compost than when we didn't. Now, not all composts are the same in their characteristics. If you have a lot of phosphorus in the compost and you're worried about surface water quality, you can find composts that have less phosphorus, all right? But regardless, I think you're going to find reductions in losses compared to controls.
Yep, and that's kind of what the research has shown through the years. Better success stopping soil movement by using compost. It's a bigger win. Last question. Do you want to? A question came up for the impact to the atmosphere with composting. You know, can you talk a little bit about CO2 coming from compost piles, comparing that to landfill greenhouse generation?
Sure. Landfill greenhouse generation, you're talking about methane, which has a much higher impact on global warming than carbon dioxide. Now, when you compost, you're continuing a natural process. So if you don't compost, it's still going to decompose elsewhere, and you're still going to have that carbon dioxide going off. So there's no real contribution to carbon dioxide from composting. It's just happening more quickly and under more controlled circumstances. Much more quickly, not really. I mean, what happens in a few weeks in a compost pile would probably take 8 or 9 months out in the environment without composting. In the history of the world, from the biogeochemistry point of view, it's not really much of a difference. The big difference is by getting it out of landfills and putting it into compost piles, you're skipping that methane production problem. And methane is, I forget the number, but it's something like 44 times more of a contributor to global warming than carbon dioxide.
Okay, David, thank you for that. A great presentation, wonderful questions, everybody. Keep them rolling in. And thank you again. I'll pass it back to Brian.
Thank you, guys.
Thank you, Ron. Our next speaker, Dr. Britt Fawcett, is the Director of Research and Technical Services for Filtrex International. He is a certified professional of erosion and sediment control, a leadership in energy and environmental design accredited professional, and earned his PhD from the Odum School of Ecology at the University of Georgia. Britt serves on multiple erosion control and stormwater management technical committees with ASTM and serves as a board trustee for the Composting Council Research and Education Foundation. Britt has helped to develop state and federal specifications for compost use in erosion and sediment control in the U.S. and Europe, and authored or co-authored numerous journal articles and books on the topic. Britt will discuss the use of compost, BMPs, in treating stormwater. Britt?
Thank you, Brian. And I just want to today, I know many, if not most of you, are still working at home, and challenging work-life balance is not easy. And you've chosen to spend your time with us today and hopefully tomorrow as well. So I just want to sincerely say thank you for that. Next slide. Okay. I always like to begin with a bit of an outline of how we'll move through the next 25 minutes or so. I'm going to make the assumption that really most everybody attending the workshop has a background in stormwater management, but I'm still going to begin there because I think where we are in stormwater management today really lays the foundation of the importance of compost and really how we're using it. From there, I'm going to talk really about the what, why, and how compost functions in these applications, because there's some pretty unique applications and also types of compost that we use. And I'm really going to focus on 2 types of compost BMPs and really the research behind them and the really performance-based research. The first one is a compost filter sock, and I want you to think about that as really your treatment for stormwater, and then also a compost blanket or compost erosion control blanket, and think about that really as your prevention management practice. Next. One of my all-time favorite graphics, what this slide is, it really does a nice job of showing is as we change our land use patterns from natural systems like you see on the left, lots of vegetation, biomass, tree canopy or grasses, organic matter, carbon. And as you move to the right, with just greater land disturbance and land development, suburban and urbanization and impervious surface, what's actually happening is we're breaking the hydrologic cycle or the water cycle. And you see that in the color coordination. We get less infiltration, we get less cycling or recycling of water back up into the atmosphere. That can actually dry climates on a regional condition. And we just get more and more stormwater. And there's also now just tons of studies that show the more stormwater volume we have, the more pollution there is in that stormwater. And of course, both of those in higher amounts are getting into our receiving water bodies, leading to increased water quality impairment or reduction in water quality. So really, we don't have to look any further than what nature does on the left on how to solve and help solve these issues, and concomitantly reducing stormwater and pollution loading at the same time. Next. So I realize that almost none of us work on a watershed scale. Almost all of us work on a site scale. And that's one of the reasons why I'm sharing this slide with you. As professionals, when we make decisions in our professional lives, this is where we have the biggest impact. And there's another reason why I'm sharing this slide with you, and this is really where compost begins to fit into the equation. To begin with, if you look at the percentages of the water cycle here, they're very similar, very much the same as what you saw at the watershed level. But if you look a little closer, you see this layer of organic matter on the soil surface. Really what we're doing with compost blankets, which is really just approximately about a 2-inch thick layer of surface applied compost, we're really mimicking what you see here. And if you look at that arrow that's pointing down, 35% surface water detained or infiltrated, what happens when stormwater moves in that direction is it gets naturally filtered or biologically filtered in that process, whether it recharges groundwaters or moves just below the soil surface in what we call subsurface or interflow, and then recharges surface waters. And we're also mimicking that by putting compost-based biofilters or compost filter socks in the flow path above ground. So really the idea behind this is biomimicry, which is innovation inspired by nature. And that's really what compost blankets and compost filter socks are really about. Next slide. If you're relatively new to these applications, you might be surprised that really every national or federal agency or organization that has the ability to specify or create a guidance document for these BMPs has done so. The US EPA's National Menu of BMPs, the USDA NRCS, the Army Corps of Engineers. The first and original one was through the American Association of State Highway Transportation Officials. Most recently, the US Composting Council. And really, there's at least one jurisdictional agency, whether it's the Transportation Department or the State Environmental Protection Agency or Environmental Protection Department in each state has created a spec or a guidance document for these BMPs. In many states, both of them have. Next slide. So there's really two types of compost that we're using in these applications. The one on the left is really what I refer to as a filter media, really a biofiltration media. It's what we use in the compost filter sock applications. It's specifically designed for optimum filtration of pollutants, but also to allow the passive movement or passive flow of water. The other one is what we use for compost blankets. And that one is that this compost is designed for water absorption as well as plant growth. But there's really a third component here, and you can probably see it in the image, and that is surface roughness. For those of you who are playing at home, you know that surface roughness all by itself is actually a BMP in both erosion control and stormwater management. We're actually able to design that into the material by selecting for some of these larger particles. So key take-home message, if you're looking at both of these images and thinking, these don't look like compost to me, or the normal type of compost that I would buy at at a garden center and a bagged product, you're absolutely correct. While that type of compost may be what we consider to be a high quality compost for certain applications, it wouldn't be so for these applications simply because of the particle size. Everything else is important in a high quality mature compost, but the particle size is really what's critical to the performance of these. And there's actually quite a few referee journal articles that really evaluate the particle size importance on these applications. Next slide. So here's a list of 24 different really stormwater management best management practices, and they all use compost. The ones on the left are really construction activity or erosion and sediment control. The ones on the right are for post-construction stormwater management. I've highlighted in red text the ones that use this coarse compost biofiltration media. I'm going to talk about those first. I'm going to share some research with you related to them. It's what the compost filter sock by and large uses. And then after that, towards the end, I'm going to transition to that erosion control blanket compost media. And the ones you see, the applications you see in black font here, are going to be more related to those applications. Next slide. So I wanted to give you a visual representation of what these look like in the field. And I think you're going to see a lot more examples of these over the next 2 days of different applications. But what you see here is using it for perimeter control along a roadside, slope interruption applications, check dams, inlet protection, stacking them to make a larger sediment trap. You also see it being used in bioretention and bioswale applications as well. Next slide. Particle size matters, and it really is critical to the performance and really the design of these BMPs. So take a look at the image here and focus on the bottom where you see particle size. This is in inches, going from 1/4 at the left, moving across to 2 inches as you move from left to right. And what you'll see is as you move across that scale and those particles get bigger, what happens is the water flow through rate increases and the filtration ability goes down. This is really no different. Basically what happens is we're increasing the pore spaces in the material or in the media. In filtration parlance, we would call that apertures. And it's really no different than how a water filter is designed for your refrigerator or a pool or a sink, and really your air filter in your HVAC system or your automobile. You increase the pore spaces or the apertures, you get a higher flow rate, but you trap less stuff. You cinch down on those pore spaces or apertures, you restrict flow to a greater degree, and you begin to trap more things. So as we move over to the left-hand side of that scale and we select for those smaller particles all the way below 1/4 inch, consequently, this is what your bagged compost material may look like that I've implored not to use for these applications. This is what happens if you do. Basically, you're creating a dam, more or less, and a dam is not what we want out on our sites. That may work well for extremely low flow applications, but very quickly, water is gonna find a bypass. It's gonna go over top, underneath, around, and it'll be untreated. Now, consequently, that's what a straw wattle is designed to do. It really has no appreciable flow through rate, and it does act like a dam. Silt fences are also designed in a similar fashion, designed to greatly restrict flow to pond water and deposit sediments. And because we often see that, that's what the thing that makes them initially work is also the thing that leads to their failure in the field. Next slide. Oops, go back one, Jack. There we go. Thank you. One of the things that's really unique about compost filter socks and compost biofilters is there's really a 3-way filtration or biofiltration process. And the first one is not incredibly unique. And I've already talked about and described it. We're manipulating particle sizes, creating pore spaces, and that allows the passive flow of water, and we're trapping particulates and sediments. That's not incredibly unique. What is unique are really the next two, and there's a chemical component, and I don't mean we're adding chemicals here, but we know that, Dr. Crone described this in his presentation, that a high quality mature compost has per particle has a very high surface area and has the ability to adsorb or sorb some of the soluble form pollutants that we're trying to trap in stormwater. Ammonium, nitrogen, and a variety of metals are good examples of those. In fact, the US EPA has advocated for many years, they even have a guidance manual on this, to use compost in polluted soil applications to target some of the very same pollutants. And now we're using it in a water context as well. There's a biological component, and we know that let me back up. If the material hasn't gone through this composting process, like say just a wood chip or a mulch material, it doesn't have this high surface area per particle that allows for the trapping of these, and it doesn't have that sorption capacity either. A lot of folks may be familiar with an activated carbon or charcoal that's used to filter water. It's the exact same concept, just compost doesn't have the degree of surface area that an activated carbon does. There's a biological component too, and we know that a mature, high quality compost has both a high population density as well as diversity of beneficial bacteria that can both target and transform some of the very pollutants that we're trying to that we're trapping in the system, and by targeting them and helping to degrade or transform them, we actually get a bit of bioremediation in situ going on here. It's really the same processes that go on in a bioretention or a rain garden or constructed wetland type application. Now there's a fourth one, and I haven't included on the slide because it's more of an option, and that is phytoremediation. So we can design certain plant materials and seed or plant them into the system to uptake some of the berry pollutants that we're trapping in the system, thereby taking them out of the flow path and increasing the capacity and longevity of the filter itself. Next slide. So I want to share some of the key research behind compost filter socks and biofilters. This is a study that was done at the USDA Ag Research Service, published in the Journal of Soil and Water Conservation, and they looked at the percent reduction in suspended solids as well as turbidity with a compost filter sock compared to a silt fence. You can see the values there. Next slide. A similar study, and this was done at the University of Georgia, published in the same journal, different issue, looking at suspended solids reduction on large-scale field test plots. And really two key things came out of this study. Number one, they found that compost filter socks perform significantly better than other natural type materials used for sediment control, like wood chip berms and straw bales. But they also found that a larger diameter compost filter sock didn't improve removal efficiency of sediment. They found that the main reason to go to a larger compost sock is to handle greater drainage area or longer slope lengths, meaning more storage capacity within the system. Next slide. And for those of you in California, you'll appreciate this one. This one was done at San Diego State University. They looked at the total solids, or really the total sediment reduction capabilities of a compost filter sock compared to a straw wattle. They used a large-scale ASTM test method typically used for erosion control materials. You can see the removal rates there on the right-hand side. Next slide. And then finally, the USDA Ag Research Service wanted to take a look at how these compost sock biofilters could target pollutants beyond just sediment. So using it in more of a post-construction stormwater treatment context or application. And so we know there's quite a few studies now that show that the total pollutant load in post-construction stormwater can be on average about 80% of the total pollutant load. So you need treatment systems and applications that can target these soluble form pollutants. So pollutants that are not attached to particulates or sediments, whereas wattles and silt fences and the like are not going to be able to work in these types of applications. And that's really what the premise behind this study was, moving past the TSS and the turbidity, removal efficiency here. All these are in the soluble form of stormwater pollutant in these studies. Nitrogen species, phosphorus, total coliform and E. coli bacteria removal. They looked at a variety of metals: copper, cadmium, chromium, nickel, lead, and zinc. And they also looked at hydrocarbons, motor oil, and diesel fuel. And the results from this study has been published jointly in the Journal of Environmental Quality and the Journal of Stormwater Conservation. Next slide. So I want to summarize just some of the key advantages for these compost filter socks. And really, a lot of this comes from talking to practitioners in the field, whether they're designers or engineers or landscape architects or contractors. And these are really some of the top things that I hear from them. One is they like that it's natural and biodegradable, and really the material, and can and really should be left on site. Compost being left on site is really good for current and future soil quality. And it also eliminates what can be a pretty expensive removal and disposal costs associated with other types of sediment control BMPs. Most notable, it's now 100% natural and biodegradable. There are biodegradable meshes that are made of cotton, as well as a more durable wood fiber. So the application can actually be left, if desired, on the site without removal, and it will all completely biodegrade and go away. It combines sort of this rare combination of both high passive flow as well as high sediment removal and pollutant removal performance that we don't really see in other types of BMPs. It's really the only BMP, or one of the only BMPs, that doesn't require it to be trenched in, or in some cases, like in California and the state of Washington, they do have an option for a rope lashover method. It doesn't require either one of those, and that's also pretty unique to this BMP. Comes in a variety of sizes, from 5-inch diameter all the way up to 24-inch diameter. And what's pretty interesting about this 5-inch diameter is it is a relatively new application that I think is being used quite a bit for slope interruption applications. But it was used pretty widely in the tragic Camp Fire in Northern California. And it was used successfully up there for post-fire sediment and stormwater treatment applications. I think they used over 1 million feet up there with a lot of success. And it's just versatile. You can use it for the same BMP for perimeter control, slope interruption, check dam, inlet protection, stockpile protections, sediment trap applications for larger sediment control needs, and then also for post-construction stormwater treatment. Jack, next slide. So I'm going to transition now and talk about the other compost media here, the compost erosion control blanket media, and some of the research and applications there. Next slide. So really, there's 4 key reasons why a compost blanket works and performs the way that it does. And David talked about these in his presentation as well. Number 1, whenever you cover a bare soil, you're preventing that first stage of erosion, which is splash erosion or soil particle dislodgement. Picture when raindrops come down, they actually almost till up the soil. They loosen up soil particles, they break up soil aggregates, and they loosen it up. Now, it's not necessarily a water quality issue all by itself, but it's created the optimum conditions for the transport of those loosened soil particles. Now we call it sediment. We prevent that from occurring when you cover it with a compost blanket. Number 2, these things are actually natural megasponges. And because of the porosity, because of the surface area, because of the high organic matter content, they actually hold an immense amount of rainfall right there at the soil surface. And if you're holding that moisture there, what happens is that you allow for natural rates of infiltration to go into the soil below. You're beginning to restore those natural evaporation rates going back up into the atmosphere. And you can see conceptually, you're beginning to restore that natural water cycle or hydrologic cycle. It's the smaller particles that really help to do that. It's the larger particles that do the third one, and that is once it does reach its water holding capacity or its field capacity and it can no longer absorb anymore and you do get runoff, you want to keep it as slow as possible. And by keeping it slow, it's less destructive, it's less erosive in nature, it actually transports less pollution in the process. And if it's slow, it actually will find pockets of infiltration as it moves across the landscape as well. So it's the larger particles that do this. It's the surface roughness that has been designed right into the material. And then, of course, the last one, compost, is pretty darn good for establishing and sustaining vegetation as well. Next slide.
Britt, we're at the 3-minute mark.
Okay, thank you. This is a study at the University of Georgia, published in the Journal of Stormwater Conservation, that showed that a compost blanket on average could absorb 84% of a 4-inch rainfall event. So think about that for a moment. If you're absorbing that much rainfall, 95% of the events that we're going to see, which are 1/4 inch, 1/2 inch, 3/4 inch, 1 inch, you're absorbing all of that rainfall or nearly all of that rainfall. And if that's the case, you have almost no runoff or no runoff at all. If there's no runoff, there's no erosion. If there's no runoff, there's no transport of pollutants. That can have a pretty profound impact, not just on erosion control, but in the post-construction environment, really minimizing impact on both green infrastructure and gray infrastructure practices. Next slide. These are 4 university studies that all bear this out. I could probably add David's study to this as well, and probably should, showing the vast stormwater volumetric reduction of compost blankets in these applications, really roughly between 50% and 90% reduction. Next slide. Similar for reducing that peak flow rate, same studies between 36% and nearly 80% reduction. Next slide. These are 4 university studies that compared a compost blanket, a seeded compost blanket, to the way that to a way that we conventionally establish vegetation on disturbed soils or construction site soils. And I've put that in parentheses in each one of the studies. So what you're looking at here is these percentages are the percent reduction in pollutant loads associated with the compost blanket relative to the conventional form of vegetation establishment. And a couple of things, you see a trend here, not only across all of these studies and across pollutant types, both for nutrients and for sediment, which is really erosion control in this case. But there's one key reason, or one big reason why this is occurring, and that is because the compost is absorbing so much rainfall, thereby minimizing runoff. When you do that, you also concomitantly minimize pollution transport as well. We're seeing that across these studies. Next slide. And then finally, for those in California, I thought you'd be very interested in this one. This was a study that was done at San Diego State University, published in the Journal of Environmental Quality. This is was conducted on a conducted on a 2-to-1 slope, so a pretty steep slope, and looked at a variety of erosion control practices. And to my knowledge, this is the largest comparative erosion control practice study that's been published in a referee journal, to my knowledge. You can look at the different erosion control practices, but one of the things that they did here is they looked at various depths or thicknesses of a compost blanket, 1/2 inch, 1 inch, and 2 inch. I've highlighted the 2-inch blanket, compost blanket, because that's the most typical way that compost blankets are applied. And the way that this event works is they're on large-scale test beds using an ASTM standard test method for erosion control materials on pretty intense storm events, 2 inches per hour, 4 inches per hour, and 6 inch per hour intensities for a 1-hour duration in total. And so you can see I've highlighted in red there the percent reductions in erosion or really sediment coming off of the test bed for each of these. And you can see no matter the storm intensity, the compost blanket performed as well, if not better, than really all of these other type of widely used erosion control practices. So with that, next slide, Jack. With that, I'll turn it over to Ron. I think we have some time for questions.
Yep, thank you for that, Britt. We have about 4 minutes for questions. We got some good questions. There were some questions asked that I think towards the end of your presentation you answered. Here's a really good question that came up near the end of the presentation. Does the compost feedstock affect suitability for its use in stormwater management, manure-based, green waste-based versus biosolids? Should we be focusing on compost whose feedstocks were more from woody materials, higher in lignin, etc.?
That's an excellent question. It kind of depends on the application. We find that the higher carbon to nitrogen ratio materials often work better in these applications. So that is selecting more towards those yard waste and green waste type materials, not to exclude any of the others, because I think they all really work well in these applications, but we find that by and large that those work really well, really all the time if you're paying attention. But the one thing I will say is, as long as you're following the specifications in the guidance document on the type of compost to be used for both particle size and the quality, that's really your key indicator to make sure that you're going to get good performance in the field with any of these applications.
Okay, that's great. Question came up is, I don't know if you've studied, is there a bacteria to fungi ratio in the compost that works best for biological filtration?
I personally haven't studied that or evaluated that. I know that I know some other folks have looked at it, and it's a question that does come up. Because I haven't looked at it specifically, I can't speak to that.
Okay.
Yeah.
Okay. What is the cost comparison difference between a straw wattle and a sock, and how is it shipped? Is it shipped on pallets and such?
Yeah, excellent question. So, generally speaking, the initial upfront cost of a straw wattle, depending on where you are, can be a little bit cheaper. A lot of folks now are talking about the total cost or the life cycle cost of these applications, where although the initial upfront cost may be a little bit cheaper, you'll find that there's less maintenance involved, less cost on installation involved, less removal. And I talked about this a little bit in one of the slides, less cost to remove, and certainly disposal as well. And so when you look at all of those, it's vastly cheaper with the compost filter sock relative to the straw wattle. And it generally does come on a pallet, pre-manufactured on a pallet, and then drop shipped at sites. I think in some locations you can have it manufactured on site as well, using blower tray technology.
Okay, I think our time is about up, so I'm going to have to end there. There are some additional really good questions, and we're going to save them, and we're going to fit them in, and we're going to save them for the end of the event, and we'll find ways to ask some of these really good questions. Okay, thank you, Brian, and thanks, Britt.
Thank you, Ron.
Thank you, Ron. Our next speaker, Mike Ferrara, is a senior landscape architect with Caltrans Office of Roadside Management, responsible for coordinating the production of roadside policy, procedures, and standards. Mike holds a Master of Landscape Architecture degree from Utah State University and a Professional Project Manager certificate from the Project Management Institute. Mike uses his 30 years of professional experience to coordinate with designers and contractors in the development of erosion control and compost contract specifications for the reduction of stormwater runoff and sedimentation, maintenance of water quality, and improvement of soil and plant health. Mike will discuss Caltrans compost and compost-based standard specifications, special provisions and bid items, and the history and background of the construction contract work items that utilize compost. Mike?
Thank you, Brian. So we're going to talk in the next 25 minutes or so about a little bit about our specifications and our standards that we use to produce construction contracts. But first, we're going to talk a little bit about Caltrans in California. Caltrans is very large. We have 25,000 employees, and we have about 9,000 engineers, 400 landscape architects. We also have probably at least that many environmental planners and some really good IT staff that are helping us put on this event right now. There's virtually, because of all the brain power we have, almost nothing that we can't do. It's a really great place to work. It's a large state, so we're divided across the state in 12 different district offices. And it's an interesting relationship with so many district offices and having their own corporate culture, so to speak, and then all of them having to report to us over in headquarters, which is in downtown Sacramento, just across the street from the Capitol. Caltrans has a very large budget. We average about 500 plus projects per year. These are transportation projects, obviously. And depending on funding sources that are available in that particular year, it could be anywhere from $6 to $10 billion worth of contracts that are being constructed during that 1 year period. Many folks think that we construct our own contracts, and that's a myth. We have an elaborate bidding process. It's done mostly electronically, in which we have competition for our contracts, and most of the time we're going to be bidding to the lowest bidder on those, but not all the time. The system is really large. We have about 170,000 miles of highway and about 32,000 acres of landscaping that we're currently maintaining and adding to every year. To kind of give you a picture of what 32,000 acres looks like, it's about roughly the size, pretty close actually, to the size of San Francisco County. And the city and the county, in fact, have the same boundary. So if you can imagine the size of San Francisco, that's how much landscaping that we have to maintain currently. The standards that we're going to discuss a little bit more in detail in this presentation are developed mostly from a bottom-up process. Now we have a committee of mostly landscape architects, not entirely, that meet together on a regular basis, and they represent the districts, and the districts propose improvements and additions to our standards for their construction contracts. Next slide. The geography of California is, to put it in one word, absolutely amazing. As someone who spends a lot of time with outdoor hobbies, there's really nothing you can't do within the state. It's a large state, 250 miles wide, and also 800 miles long. It's the third largest state behind Alaska and Texas. It's number one in population. We have 40 million people living in our state now. The next closest is Texas at 30 million, but it also has a lot of rural areas. That's a mistake on the 37th state in density. We're the 13th state in density. And so our populations tend to be more concentrated. But there is a lot of our projects we can discuss in a minute that are in very, very rural and sometimes difficult places to get to. The variety of terrain that we work in also is nothing short of amazing. The state has the lowest point in the United States, and everybody knows well, is Death Valley. But we also have the highest point in the lower contiguous 48 states. That's Mount Whitney. And the fact is that those 2 points are within a 2 hours drive of each other, a little less than 100 miles from each other. More specifically, When you look at the plant zones and Sunset Magazine plant zones, the state has 20 of the 24 zones, or if you're using USDA's zones, we have 16 of the 20 USDA zones. So lots of variety and also challenges in our projects as we work across the state. Next slide. So we're going to focus for this presentation on just these 4 items. We have the blanket, which the 2 previous speakers have been a real nice job of talking about, and we do that at Caltrans. Compost sock is very popular here. We'll talk a little bit about that, and then a little bit more about berms. And then we also have a separate bid item. We pay separate for the labor for incorporating the compost. Next slide. This is an actual bid package. I just clipped it out of one that you can pull it up electronically. It's open to the public, and this is what you'll see on a Caltrans project. You know, when you're bidding on it, you'll see an item for compost sock, typically if there's some stormwater concerns, and they'll bid on that. And then you'll have the other item of compost in cubic yards. And my point with this slide is that that is the bid item for berm and for blanket. It's all we purchased by the material, and we bid by the material by the cubic yard. You also see down below I clipped out the separate labor item we pay for when we incorporate the compost material into the soil. That's what that bid item would look like. Next slide. The method we use is fairly recent for erosion control. We pulled a lot of what we were doing in the specifications and now are more graphically representing what we want on our erosion control on our plan sheets. We kind of call it our cake recipe, so to speak. When you look at this table, you know, we lay out the different steps that we want. Often the erosion control is a stepped process, and you can see that here. And then we show the rates over in the 3rd column, what we want for each of those materials. Next slide. We also have a standard plan, and that plan is available for any contract at Caltrans. They essentially just point to it in the contract, and then it exists in a book for the contractor to look up. And here's our standard plan for our compost sock. We used to have it available for construction with the lashing method, but we got some feedback from the field and the contractors that they prefer the staking method. It seems to be a little easier, so we now are strongly encouraging that. You can see with the detail with the stake through the middle of the compost sock, and then a note you're not able to read below it says you can also place the stakes at the bottom of the sock. If you can look also, we encourage the overlapping too when you have different lengths of sock that you're trying to place on the slope. And keep in mind, when you work at Caltrans, you become an expert at steep slopes. Even places like San Diego, which relatively arid, some would think more desert, the slopes are commonly 2 to 1 or even steeper. And we regularly deal with slopes that are over 100 feet in length at those inclines. And so that adds additional challenges to us when we start talking about blankets in particular, and whether or not they're going to stay on the slope. It's really project dependent on that's going to happen. We've had, you know, it's a very arid state too, especially the lower part, the southern part of it, and or some areas with wind we have to contend with. So, and you might imagine a windy place with dry compost blanket can be a challenge for us. So It's we have many tools though, depending on the project, on what they can do using compost. Next slide. So here's what the specifications look like. We have a foundational book called the standard specification on our contracts. Everything keys off of that standard specification. So you go there first when you work on one of our contracts to look at what's required. And then on top of that, we also have special provisions that are more specific to that project that work hand in hand with the standard specification. And we also have something called revised standard specifications, a way of making improvements to it without having to republish the standard specifications every time we have a change. So those are like the three main written parts of the contract you're working with, along with the boilerplates that's in with every contract, and then the standard plan that I showed you, and then the project plans and the bid of mine I showed you. Those are the parts of the contract that anybody that does our work has to get very familiar with, and our designers are very familiar with. I point out to this one, there's a technical data sheet under a compost. I put a little red box around it to show you that that's an important part of the process of construction. We also have the code of regulations. That is really mostly focusing on the compost producers. We're pretty highly regulated, and I'll give you a little more detail on that on the next slide, please. That's what a technical data sheet looks like that we would get during construction. It's under the U.S. Composting Council, and we'll show some of the quality measurements that we're looking for. It's just an example of what one would look like. That would be part of the construction process. That would have to be acceptable to somebody we call the resident engineer, who speaks on behalf of the department during construction and tells the contractor whether or not we're at an acceptable level for them to go ahead and apply the compost. Next slide, please. These are the regulations that are mostly focusing on the compost distributors, compost suppliers. There's a lot there you can see about metal concentrations and pathogens and you know, the levels that need to be required from them. Also, there's more and more on vegetative food material, which is becoming, see at the bottom there, more and more or a greater source of material for our composting. There's a lot of grocery stores in California, as you might imagine, and there is more than ever in the last few years, more and more of our composts. There is legislation, in fact, trying to encourage more and more of that food waste that Dr. Cohn showed, all those watermelons. That's a common sight here. Thank you. The next slide. This slide, I bring that up to show, you know, this is part of the specifications for our compost. If you look at the second sentence, we make it optional on the application with a blower truck. I think many of our contractors, in fact, some that are here on the panel, will say that is usually the optimum way to apply the compost, particularly blankets, but it is optional depending on the size of the site and economic efficiencies that the contractor needs to meet. The other thing I want to point to in this spec is if you look at the last sentence, it talks about you know, don't apply it within 3 feet of the edge of pavement. In the transportation world, there's something called a clear recovery zone. That's if your vehicle, for whatever reason, comes off the highway, it needs to have an area to be able to recover safely, ideally, is what we try to provide for them. And typically that's a minimum about 30 feet. And there's some concern from many of our engineers and our managers that if we start applying compost or doing any other activities in the landscape that create very soft soil condition, uncompacted condition, less than 90%, within the first few feet of the edge of the pavement, that may in fact perhaps be an unsafe condition. So we have to be careful in our work, both in our planting, but also in our stormwater work, in our compost work, and that first few feet, 3 feet or so off the edge of the pavement. Next slide. Here's the beginning of the specification for our compost. It shows the different sources we take, and I pointed to the food waste number 4. That's getting to be a greater portion, but it also can be from other biosolids, solids, from wastewater, manure, and other typical vegetative materials you get from our trash bins in the front of our house, or from firms who are doing tree trimming services. If you go further down on that slide, you can see again, we're pointing to that same code of regulations here on that for the suppliers. Next slide. This is our special provision. If you remember, that's something that goes along with the standard specification. It's more specific to the project. These are our quality measurements we insist on for our compost. We make a distinction in the columns on the right between a fine compost and a medium coarse. The quality measurements have to be perhaps a little bit different for physical contaminants on the more coarse, given that it's not sifted as finely, and a little bit more if you look at the stability too, because you're dealing with a greater size of material. We use the test methods you can see here from the U.S. Compost Council. We point to those in order to come up with these numeric evaluations of the quality of the compost. Next slide. This is the second half of that special provision. It's a really, I show that to you to show we have a really wide range of size of compost that we can use on our projects. You can look at the fine down to 3/8 inch compost we typically see in our gardens, all the way up to 3-inch size down below that you'll see up to that in some of the compost socks that Dr. Fawcett was talking about. So really wide range. Probably, and this is only my opinion, we probably can focus a little bit more. I was really happy to see Dr. Fawcett's slide on the different uses of the coarser compost. We probably can focus a little bit more on some of those uses on the coarser that is available, and the suppliers would like us to take more of the coarse as well. So those are the ranges, and obviously there's a gradation of this in a lot of cases on many projects. Next slide. Next slide, please. I skipped one. Are you able to go back? Thank you. Compost socks have gotten very popular at Caltrans in the last 5 to 10 years. And I show in red up there, we just made that addition for the 5-inch. Dr. Foss is talking about the smaller sizes are getting more and more popular because they do the job and they're easier to construct and maybe a little less expensive. And so we're just making changes now to make that size available, but there is a range for our designers to use. And then we also, further down, you can see we have some quality measurements again for what gets put into the compost sock. If you look at the last sentence of the first paragraph, you'll see it says compost sock may be pre-filled mesh tube or filled at the job site. So we have both. We talk to the contractors. Sometimes they prefer to fill their own socks, and sometimes they prefer to buy the pre-manufactured sock. So we give them maximum flexibility there. Next slide. And then this is a pretty wide range of in our compost socks that are allowed for gradation. Obviously, you need some gradation, or you're not gonna be able to filter dirty water very well. So we get pretty wide range of that, how you could use the different sizes in order to perform well as a compost sock. Next slide. And this is the end of the presentation, but I wanted to show you, you know, being creative, we all know, and we learned that, especially in the last few months, is really important in our work. And this is kind of fascinating. This is a snow blower you'd see typically in Truckee Pass in California, which is infamous for being extremely difficult to get through during the winter time when it's snowing. And we have many of these snow blowers. And so this is a use actually during the summer instead of having them sit in the parking lot. In certain cases where there's room like this, you can windrow your compost and use it to blow it up on the slope. And that's it. Thank you.
Okay, thanks, Mike. Thanks for running us through the process of specifying the use of compost by Caltrans. We have a few questions here. First question is there a best way or a spot on the Caltrans website to see all of the Caltrans bidding projects that are going to be bid?
Yes, there is. If they use the standard website address, which is dot.ca.gov, on that first page has a click for doing business with Caltrans. And from there, you can go over to the place where all of our contracts are shown that are currently being advertised. And you can see who some of the contractors are that are bidding our contracts. And in fact, there's a place they developed for, if you're a subcontractor, how to locate the general contractors and make a case to work with them. So there is a place to do that, yes.
Okay. Another question just came in that asks about what does the reserved term mean in the standard specification for compost?
Yeah, that's just a formatting method. Reserved locations are just that. They're places where we think we're going to have to put something eventually, and because of the way the standard specs are formatted, we need to put like a holding spot in case we need it. That's all that is.
Okay, beautiful. Another question is how has Caltrans dealt with or limited film plastic allowed in compost products?
Yes, that has been a challenge in the past, and the state legislature got involved, in fact, and passed legislation to insist on less of it. And so we've ramped down, if you look at our specifications, to 0.5% in most cases. No greater than that for the film plastic. I know that the state is making a lot of efforts at the source. That means places like my home. I recently had somebody from the local waste collection company dump out my entire recycle bin and look for film plastic specifically after they had communicated to us a couple months prior to not include it in our recycle bin. So they will look and flag your bins at the source depending on where you live. But yes, that film plastic has been a challenge in the past, but we seem to be getting much better at it, is my understanding.
Right, and then on the Caltrans spec, you guys have lowered the specification for both total physical contaminants and then film contaminants are down to 0.1%, if I'm correct. So you guys,
Correct. Thank you.
yeah, you've even gone lower when it comes to that to deal with knowing that it's a lighter material. Final question is how do you, well, I actually have a quick question for you first because we have a few more minutes. What do you think, the biggest challenge is with using more compost on Caltrans projects? I mean, is compost written in specifically, or is it typically written in as just an approved equal?
Well, it's been used for, most of my career, at least 20 years. And so it's interesting, the graph that was shown early on in our presentations, how its use is very much tied to how our planting programs, how much planting are we doing, and that varies up and down depending on how much funds are available. So if we're doing more planting, we're using more compost. We do have sock use and other things now that we didn't have in the past so much for its use. But it is not a panacea, and the designers could probably better answer this. But we do have the challenges of very windy areas, dry areas, very steep areas, and then we also have, like I mentioned earlier, we have a lot of remote places we do construction activities, and there gets to be a problem with cost when we start getting more than 50 miles away from a compost supplier when we're buying it in such large bulk quantity. So all those challenges, I think we are working on them slowly, but yeah, that is some of the constraints that we have.
Okay, and then a final, just a quick question, hopefully, because we only have about a minute left, is how do you guys typically make sure that your products are meeting the quality and testing requirements from the spec?
Yeah, so if you look at the technical data sheet I showed early on, that's produced to our resident engineer, who's the person that oversees the construction. So we go by that, and we go by something called certificate of compliance, essentially, where it's paperwork, contractors promising quantity or the quality that we put in our specification. But more importantly, our designers know people, and I think we'll get more of this from Scott a little bit later. They know who the suppliers are. There's not that many suppliers. So for that particular area, they know who the suppliers are and typically the level of quality that they could expect from them, on top of, the paperwork that needs to be done in the construction site to make sure it meets the specification.
And then I'm also correct, Mike, that you guys have the ability to pull a sample and have it tested at the contractor's price, correct? A cost.
Yes, and that's just ubiquitous of anything we do in construction. We can inspect at any time, any way, pull samples, test at any time, anyway.
Yeah.
But we may formalize it a little bit more. There is a proposal from our districts to maybe formalize that a little bit more, depending on how our construction division, what their thoughts are on that. We may formalize it. But yes, you can, if there's any doubt at all, they can test at any time.
Okay. Well, thank you, Mike, for a nice presentation. Appreciate the answers. And I'll pass it back on to Brian for our last speaker of the day.
Thank you, Ron. Before we get to the next speaker, I wanted to mention a couple benefits that might not be mentioned in these workshops, but are important to the overall environmental sustainability goals and mandates of California departments like the Department of Water Resources and Air Resources Board. Compost reduces greenhouse gas emissions through carbon sequestration, increases plant available water, reduces use of synthetic fertilizer, and conserves water. Our next speaker, Matt Cotton, has over 30 years of experience in the composting industry. His company has provided technical composting-related consulting services to public and private clients in California for over 25 years. He has helped facilitate Caltrans' use of compost since the mid-1990s. Matt will discuss the United States Composting Council's Seal of Testing Assurance Program and how it assists purchasers in ensuring compost meets Caltrans specifications. Matt?
Thanks, Brian. Appreciate it. Thanks, good morning, everybody. So glad you're all here. Still mourning the fact that we're not in some Caltrans district office down in Riverside or over in St. Louis or up in Tahoe like we did back in the early aughts, but it is what it is. So just a quick shout out to Brian. I want to recognize your decades of public service and your impending retirement here. We're all gonna, just want to thank you for that, and we're all gonna miss you and appreciate all your work you've done on this. Thanks to Jack and the whole Caltrans team. Quite a team effort, and to get this done, given the situation and the various players all around the country. And I'm just really proud to be a small part of that team. As Brian said, I've been working on these issues since the mid-90s, going back, trying to put Caltrans together with composters because it's a really good way to manage erosion control. It's a great way to manage stormwater. We've learned so much over these past really 30 years or so. So shout outs to a lot of the technical experts like Ron and Britt and others around the country. We don't have folks from Davis or Cal Poly on the next 2 days workshops, but they did a lot of important work, which undergirds a lot of what we do. And so far it's been a real success on all accounts. So I'm really happy to be here. You can go to the next one, Jack. What I'm going to talk about today is something called the Seal of Testing Assurance. You've had little bits and pieces of it. You just saw the compost technical data sheet that Mike shared and gave a lot of granular detail about how the specs work. But what the Seal of Testing Assurance tries to do is really understand and put a simple label on a very complex product. We've heard some testimony today, some data showing that compost actually performs or outperforms a lot of the alternatives, but it's more complicated. It's more complicated to buy, it's more complicated to make, and that makes sense, right? It's a lot of feedstocks, different production methods, different qualities, technologies David Cronin talked about, different test methods. So what we're trying to do with the STA is bring this all together in an easy to recognize seal that sort of implies a certain amount of quality, much like USDA labels tell you what's in your cereal. It's not necessarily a diet, but it tells you what's in it, how it was made, etc. If you can go to the next one, Jack. Well, that's a great shot of some Caltrans engineers looking at compost, actually inspecting compost at the site. And I guess what I wanted to say about that is you can't really tell just by looking at it. You can look at it, you can feel it, you can smell it, and that will tell you some things, but that really doesn't tell you a whole lot. So many years ago, back in the 90s, we came up with the Seal of Testing Assurance to try to encapsulate all the testing that composters do to standardize the test methods, standardize the frequency of testing, so that when people are actually buying compost from a compost manufacturing facility, they have a certain confidence, a certain guarantee that it's been through certain processes and they can expect certain performance from it. Because a lot of materials out there, Mike can tell you, or talk for days about other materials encountered out there in the universe that are not compost, do not go through the processes that David talked about. And that's really important that you get compost, it's gone through the process, it meets state regulations, been through testing with the right tests, the compost tests, not water tests, not soil tests. So we'd like to say, if it is an STA certified compost, what is it? And again, I think this is a tool that's really helped both compost manufacturers to understand what the tests are that are needed, but also Caltrans engineers and what they're buying, what they're specifying, what they're procuring. So go to the next one, Jack. So fundamentally, again, the STA program is a testing, labeling, and information disclosure program. California is already pretty progressive in this sense, but across the country, there are states that don't require testing, don't require this level of information disclosure. So most California composters are required to do regular testing, and if they're participants in the STA program, they're disclosing that information, providing some use guidelines, so really helping the consumer, in this case Caltrans or other engineers, making good purchasing decisions, improving customer confidence, buying the right product for the right project, hopefully enhancing compost position as a mainstream horticultural and agricultural retail product. 65% of the compost we make here in California goes to ag, so trying to make compost for 32,000 acres, not that big a deal, not a huge market here in California, but an important one. But again, at the end of the day, to distinguish compost from other organic products. Lots more information at the URL there at the U.S. Composting Council. Links to specs, links to facilities, link to projects, a whole lot of stuff there. So go ahead and go to the next one, Jack. And just some examples. Again, we've been working for decades with Caltrans and other universities, other DOTs. Folks like Ron Alexander have been working with DOTs for decades in other states, putting together projects, putting together specifications, trying to find the best possible application of compost for a particular use to get the performance you're looking at. These are some pretty steep slopes up off of the 80. They're looking at some combinations of BMPs to enhance or minimize runoff and control. So go ahead and go to the next one, Jack. Again, hoping to get folks to use the right products, all the stuff that Britt talked about, so that we get good performance, we get predictive performance, we understand what's going to happen. We don't have failures in the field. Nobody likes to see that. We want both end users and composters to have a good experience and have the right products and the right jobs and get the performance they expect. I think that's Ron's lawn there. It's looking not so good. Go ahead and go to the next one, Jack. So fundamentally, most of the obligations of the STA program fall on the composters. They've got to comply with local and state permits. They've got to meet the definition of a manufactured compost product. They use this document called the test methods for the examination of compost and composting, which include sampling methods, testing methods, handling methods, and there's a frequency prescribed based on the volume. Here in California, any commercial manufacturer has to test, go through this battery of tests every 5,000 cubic yards. They're using STA labs, which are pre-certified. There's actually a lab proficiency program run out of Colorado State, which actually looks at the proficiency of the specific tests that we're using and what the allowances are on those. You've got to pass EPA, or in our case, California pathogens, metals, and inert contaminants. That just came up in the previous conversation. So, and there are subtleties or additional parts. The consumer use program looks at different limits for different parameters. That's not too relevant here, and you're disclosing these test results and the ingredients. What was the feedstock? What was the process? How did the tests look? And providing directions for use. So just like any other retail, horticultural, agricultural product market in the U.S., composting is an emerging field, even though some of us have been doing this for decades. We've seen the industry grow. We've seen it become much more professional, much more of a manufacturing process. But there are smaller facilities out there that still struggle with some of this. So this provides a format, some consistency, some consistent reporting, and some benchmarks to shoot for. So again, all these are available on the website there, the U.S. Composting Council website, down at the bottom. You can go ahead and go to the next one, Jack. Again, fundamentally, specific compost information is disclosed to customers with the USCC oversight using a standardized form. That's the compost technical data sheet that Mike mentioned. For DOTs like Caltrans with STA specs, it's a compliance cheat sheet, so you can look at that, get all the information you need. Once you get a load of compost, you get the CDTS, you can look at it, review it, understand what you ordered, what you thought you were getting versus what you actually got. The lab test results are there, the ingredients are there, the use instructions are there. And again, providing you a level of certainty that what you purchased and what you spec is actually what you're getting. And I know that can be a multi-party affair here in California sometimes, but it's providing a certain level of certainty and hopefully an increased level of performance and success when you're buying compost from different folks. You can go to the next one, Jack. Here is that technical data sheet. That's probably a little small to see. That is available on the USCC website. It's probably available if you look hard on the Caltrans website, but looking at different parameters, particle size, pH, passing the environmental health and safety standards we talked about. Again, it's sort of a like that ingredient list on your cereal box telling you what's in it and what those numbers are. Not really telling you how to use it so much, but at least that it's a product, it's been tested, and here's, in fact, what those test results were. And I apologize, that's a little small to look at. There's an awful lot of information packed into one sheet, which is exactly the way it was designed. So you can look at that pretty quickly and get some understanding of what you're getting, especially if you're getting multiple loads over a large amount of time, as some jobs do. So go ahead and move forward, Jack. Okay, so here are just a quick listing of the 51 STA facilities in California. There's about 80 large commercial composters in California. There's probably 160 composters, permitted composters, but many of those are really small local facilities, about 80 big ones, about 51 of those, including the very largest ones, are here, part of the STA program. It's gotten great acceptance. Big composters, high quality composters all over the state. And you can find a list of those with links to their salespeople, to the facility at that URL there, which will be up. Eventually, these will be provided on the Caltrans website, and shout out to folks. So, but a lot of big, significant manufacturers here in California, part of the program, regular participants, support the program, and other efforts that we do here at the U.S. Composting Council. You can go ahead, Jack. Okay, so here's a map, quickly, roughly showing where these facilities are. Generally, you're going to find these large manufacturing facilities around population centers, obviously grouping around the LA Basin, certainly the San Francisco Bay Area, and of course in the Central Valley. And the numbers have been improving. The numbers maybe aren't as important as the total tons that are covered. I don't have that number, but it's clearly 75% of the tons manufactured in California are probably covered under the STA program. So way back in the day when I was working with guys like John Haynes at Caltrans and others, John would call me up and say, "Hey, I'm up in Modoc, where can I find some compost?" And we'd spend some time trying to find the most closest, efficient composter for him to buy compost from. It was a pretty clunky process for him to have to call me to do that. So now we've got the map. These are all available on the web, and really a lot easier to find these days. All these, of course, are listed on the USCC's website. They're all available on the Cal Recycle website. Not that hard to find these days in the era of websites and better marketing. So really shouldn't have I know Caltrans works all over the state. It's a massive state, very long state, miles of freeway, but there really shouldn't be a whole lot of folks struggling to find compost. Now, I know certain projects, you're going to be in some remote corner of the state. It's going to be a challenge. Transportation is going to be tough. That's probably true for most of your alternatives out there. So, but in the more urban areas, you're going to have pretty good access to good quality commercial compost pretty regularly. So take a look at that. You can go ahead, Jack. And again, just trying to highlight the fact this is not new. Some of you participating have probably been following along for a long time. Others may be new to this, but this idea of compost use by departments of transportation in both landscaping and erosion control applications is really widespread. Folks in Maine, folks in New York, folks Ron has worked with for decades have really been doing this for a long time. And again, it's undergirded with research that Britt mentioned, and you can find with a quick Google search, lots of stuff from Cal Poly, lots of stuff through UC Davis, other universities around the country. San Diego State was mentioned a few times. There's really a lot of support for the efficacy of this material in these applications. And so the requirement of the STA is becoming more and more popular with specifying agencies, whether that's Caltrans or ODOT or WashDOT or whoever it might be. And also you're going to see a lot of cities and counties piggybacking on top of that as certain legislation like SB 1383 that Neil mentioned earlier looks to find more jurisdictions speccing more compost to meet their obligations for procurement. So a lot of folks are going to be looking at Caltrans, seeing what your experience has been and trying these in spaces that they manage, whether they're steep slopes or roadways and parks, et cetera. So again, a lot of success here. It's been actually quite satisfying to see how this started as a pretty niche application back in the early 90s and has really expanded and become much more mainstream and better understood, better applied, much better, many success stories out there. So while this may seem new to some of the engineers out there, and may not be as common as, straw wattles and, silt fence and stuff, which are ubiquitous. But if you're really looking to find something that performs, really works in a really challenging situation, there's really few products that can meet what compost does. Move ahead, Jack. So, what if there isn't an STA supplier or one with enough supply on hand for a bid? There are ways to get material vetted pretty quickly. There are other ways to tag team if you just have a small composter in your area. But you really do want to buy compost in this program. There's, again, a lot of support behind it, a lot of testing. When you're buying something that is not in this program, does not have the testing and the assurance, you're really opening yourself up to a lot of uncertainty, a lot of questions, a lot of performance issues. So you really want to be careful when you're doing that. And again, as you can see through the brochure, there's a lot of resources both within Caltrans and CalRecycle and the compost industry that can help you find that. I'm sure if there isn't enough supply in a specific location, that person can probably network with their colleagues and find material for you. Again, lots of language. If you're looking for alternative spec language, tremendous amount of resources on the U.S. Composting Council website, on the CalRecycle website. So again, lots of resources, and the folks who are presenting both today and tomorrow, as far as trying to get the right specification for your specific job, trying to support that with perhaps a case study or some underlying research to understand what kind of performance you might expect. There is a lot of data out there. I know websites don't always stay up to date, but there is a tremendous amount of information out there if you look even a little bit hard for it. What you're doing has probably been done somewhere before, and there's probably some good stuff you can find to help support what you're trying to do. Go ahead, Jack. So again, this is the STA lab sheets. Other states are using this, and the Caltrans example just as a way to meet the specs and really understand what you're getting, documenting what you've gotten, what you're purchasing, what the various parameters are for what you've purchased and how those might perform. Go ahead and go to the next one, Jack. So I'm not going to go through these, but as Britt mentioned, and as Ron will mention, and speakers tomorrow will mention, there are lots of applications. I know Caltrans does a whole world's worth of work on this great state, this big state of ours, different soil types, different conditions, obviously different slope steepnesses, things, but lots of ways to use compost to get a good result, to stabilize those slopes, to minimize the impact on stormwater, get that water absorbed in place, and to beautify the landscape. So we have all sorts of case studies, again, on the Caltrans websites, on the CalRecycle websites, plenty on the U.S. Composting Council websites. So again, if you've got a project in mind, you're thinking about, you want to use compost, probably somebody who's done something reasonably similar, probably in California, certainly around the country, whether it's wetland restoration or just slope stabilization, managing stormwater in all sorts of different situations. A lot of work has been done by a lot of folks over the years. So hopefully you can avail yourself of those resources and find some support for what you want to do, because the material's out there and it's of a quality that will really get you the performance you need. You can go ahead and move forward, Jack. This is what I really wanted to highlight. This is what I actually do in my real job. I don't work for the U.S. Composting Council. I had a lot to do with some of the STA in the early days and the California Compost Quality Council, and bringing together some of the folks that really got us to where we are today. But this is a study I did for CalRecycle. It's a year old now, but this data, I've done these statewide studies of compost manufacturers 4 times now, starting back in I think the first one was 2008, but I'm sorry, 2004. But anyway, this is looking at what the market looks like statewide. As I mentioned, agriculture uses 65% of the compost. In California, that's not too surprising in a state with this much agriculture, this much diversity of crops. But Caltrans in the most recent study was 5%, so which is up from 1% in the previous study. So the use by Caltrans is increasing, whether that's mulch or compost. This study looked particularly at compost, so that may be why that number is a little bit larger than it was in previous years. But we do see more use as more material gets available, as the word gets out, as people have confidence in the products they're getting, understand what they're doing, and attend seminars like this and educate themselves about how this compost stuff might actually work for them and provide the benefits they're looking for. So just wanted to highlight that. That's some relatively new information. That study is on the CalRecycle website if you're interested in digging into it. You can go ahead and move forward, Jack. So in the end, if it isn't certified STA compost, what is it? I'm doing this on behalf of Hillary Nichols, who's really, it's really Hillary's job to administer the STA program at the USCC. Of course, with travel restrictions and everything, she's back in North Carolina, but you can get a hold of her if you have questions, want a list of composters, or dig into the spec sheets, or understand who's available in your neighborhood. That's a great resource. Contact Hillary and she can help you out with all sorts of details with the program. If there are composters on the line and you want to be part of this program and you're not part, that's definitely somebody you want to get to know and understand what it takes to submit your products to the STA program. So you can go ahead and move forward, Jack. We can just move that one off. That was going to be an invitation to come to our annual conference in Ontario. And guess what? We're not going to be doing an annual conference in Ontario because there's this incredible, horrible global pandemic happening. So that's going to be a virtual conference. So if you have lots of questions about compost and want to learn more, there probably will be some stormwater erosion control type content there, but that'll be coming up. We're still working on that, given all the other steps. But with that, I'd be happy to take any questions.
Okay, thanks for that. Thanks for that, Matt. Hey, by the way, so Matt, that study that Matt was talking about that he and his firm completed was the SB 1383 infrastructure and market analysis. And Matt, you said that 65% of the compost was being marketed to agriculture. Is there a number? Do you have an ongoing number in your brain of how much the study said was actually generated in the state? That was a question that came up earlier.
It's only around 5 million tons. I don't think we came up with quite that number for this study, but roughly 5 million tons, something like that.
Okay, great.
That's what I remember. Maybe it's a little bit lower than that, but that's what I recall right at the moment. I don't have it in front of me, of course, because I'm an idiot. But
okay, somebody asked what my British friends would call a cheeky question, and that is, do you see the cost of compost coming down? If so, how do we get the product to be less costly?
That's a great question. I don't think that's a cheeky
we do live in
question at all.
America, right?
As far as I can tell, I don't know. What's interesting, and I think more relevant, in some ways you might predict us. So as Neil mentioned this morning, SB 1383 seeks to increase or decrease the amount of food going into landfills, food and other organic waste going to landfills. Presumably much of that's going to go to compost. We anticipate, certainly Cal Recycle anticipates the supply of compost increasing. Normally you might assume that means the price would go down. I don't know. I haven't thought about that enough. And, in some cases, certainly in many situations where Caltrans is using compost, if they're close to a manufacturer, then sure, perhaps the price is going to come down a little bit. But an increased supply is not going to change the cost of transportation. And sometimes, as you know, Ron, the cost of transportation can unfortunately outweigh the total cost of the product, just because it's a heavy, wet material you don't want to haul a whole long way, or if you do, it costs a lot of money. So I don't have a good answer for that.
Yep, and I do think it's important that question was asked, because the question always has to go back to the person asking that question. What are you comparing it to? Because when you're using compost on a slope to seed, and if your goal is to compare it to hydroseeding, well, it's not, the numbers aren't going to be quite comparable. But if you're looking for other benefits like managing volumes of stormwater, like Britt talked about, it's about the least expensive method there is, as well as getting your slope vegetated.
Right. What's the cost of performance? How much do you want to pay for something to fail? You can get some really cheap substitutes that are not going to do well if you want to do it twice, but I don't think you want to do that. So it's a good point.
Right. Hey, Matt, another question came up is, with 1383 coming up, what's the relationship between meeting the SB 1383 goals of communities and the use by Caltrans?
Well, there's not a direct link. I mean, I think we expect, in short, SB 1383 expects a lot more food waste to be collected from both residents and businesses and industry. So again, we'll expect the compost supply to increase. we also expect the use by Caltrans to increase as availability increases and knowledge of these practices and performance gets out. But I don't think it's a direct relationship because we have very enviable markets in California. I think some people look at these workshops and think, oh, the state wants Caltrans to use compost because nobody else wants it. And that is not the case. Right now, composters are having the seasons of their lives. Many of them are selling out or running extra shifts to try to make more compost because they can't seem to produce enough at the moment. So, Caltrans is going to be a use, but there are lots and lots of other horticultural uses. And of course, agriculture is still demanding compost. Big crops like grapes and almonds and others just using compost in increasing amounts. So we're going to make more, we're going to use more. I guess that's how I see the link, unless I misunderstood the question.
Matt, if I remember your report right, we're going to need another 5.5 million tons by 2025. Not sure how that'll impact the cost, but definitely should be a bigger supply.
Well, so CalRecycle estimates, if you look at the generation and what the goals are, that there'll be that much more compost. I hope you're right, Brian. I don't know if it'll be quite that successful, but certainly there's going to be a significant increase in the volumes of compost produced in the next 10 years because of 1383. So no shortage of supply, hopefully.
Hey, Matt, there's one final question, and I don't know if this is better answered by Jack, but the question is, has there been a discussion about including an environmental product declaration for each type of compost method or end use? Sounds to me like they're looking for some type of life cycle analysis. That's a pretty tough thing to do. Have you heard anything about that?
I have not. I'm hoping Jack will jump in. I understand the question. I don't know the answer to that. I'm not familiar with that. I have not seen that. Not familiar with any of those discussions.
I do understand that question, and we actually haven't considered that. So if you're a Caltrans person, and if you're the person I think you are, you can go ahead and just email me directly. We could actually get that started because it probably would be of value for us to take a look at that. And Matt, for you and others, what that environmental declaration is, it really takes a look at the whole life cycle of a material and what the environmental impacts of that material are. For example, we were looking at one point in time our temporary K-rail, which is made out of concrete, and looking at shifting that over to a metal K-rail, and the cost of transporting and the full life cycle cost of that material. So I think it'd be really good, and I'm sure it would show up as a positive for the department. So thank you for the suggestion.
Yeah, back in 2000, there was a national study done evaluating the use of compost on roadsides, and it was funded by the US EPA. And one of those questions was to try to come up with a figure. Can we show some carbon savings by using this material on the roadside? Major conclusions were not obtained, but I think it's a question that's going to continue to be asked. So, and that was go ahead, Matt.
I was going to say, Ron, you're certainly aware there's a lot of that work has been done on the composting side, not specific to use along the roadsides, but the benefit. Maybe Sally will talk about that some tomorrow. Even just some of the basic benefits of compost, like water holding capacity, reducing the bulk density, some of the basic benefits we talk about. If you start to analyze those on the types of square footage you're dealing with, Jack, I think you'd find a lot of benefit. But in addition to what we already know. So, project.
Yep. There was also a question or a comment that came across. I know that we're at the end of the time here, but a question came across that, or comment that compost is often compared with some newer hydroseeding materials, which cost less, but quote unquote supposedly provide the same results as compost blankets. And it basically suggests here that certain people are allured to that because it's a lower price. But I understand that comment, and there's pretty good data out there showing that it's an apples and orange comparison. Compost use is better compared to the use of blankets, rolled blankets on roadsides. They have a lot more benefits than just a simple hydroseeding application. So with that, I'll pass it back to the man who's retiring, Big Brian, and thank you, speakers.
Actually, I think it's Jack. You finish this up, don't you?
Yeah, Brian, you and I can work together on it. I want to say thank you to all of you that came to the webinar.
Jack, you're muted.
Might have been a good mute. I wanted to say thank you to everybody that came today. Improving roadside revegetation and stormwater quality with compost BMPs, part 1, day 1. We hope you all got a lot out of today. We had some excellent speakers, national experts here today, and really worldwide leaders, in my opinion, in the production and legislation and everything around compost. We're capturing all your questions as you email those in. Ron, thank you very much for today emceeing the questions. That worked really well to get those rolled up and fed over to the presenters. There are a lot more questions that you all had today. Tomorrow we've got a panel session with all of the presenters where we're going to try and capture some of the more common questions and address those, or maybe even more of the complicated questions. We'll also be working on those questions over the next couple weeks with our presenters, creating a question and answer format, put it into a document, and then we can email that out to those of you that were able to sign up via the Cisco WebEx system. And the rest that weren't able to sign up, we're hoping I can post all of this information on our external Caltrans website. If and when we get it posted, it will be posted on Caltrans Landscape Architecture Compost Workshop 2020. If you just Google something like that, it should pop up. Just so you know, in order for us to post externally on our website, it has to be what's called remediated for ADA compliance, which adds some challenge for us to be able to post information externally. So tomorrow, I wanted to cover what we're doing a little bit. Tomorrow, we start again at 9 o'clock. We'll go till about 12:30. Tomorrow, again, you've got national experts and leading experts across the world here to present some practical applications of compost. I think you'll find it extremely beneficial and you'll learn a lot. These people that have been doing this work for years and on very large scale projects, you'd be amazed at what you learn when you listen to these individuals and pay attention to what's been going on for several years with compost applications. So tomorrow we start again at 9 o'clock, and hopefully you've all got, at this point, the YouTube link. Please pay attention to the links. We've got 2 separate links. So today was one link. Tomorrow is a separate YouTube live link. And Brian, is there anything else you want to say before we adjourn?
I just want to thank everyone, all the speakers today. They did a great job. I would like to mention also that this is being recorded. So if you want to look at it in the future, that will be posted. Not sure how long that'll take Caltrans to get that up, but probably within a few days, it should be available if you wanted to go back and look at anything. Should be a great show tomorrow. We've got some great speakers. We're looking forward to it. Hope to see you all there.
Excellent. And thank all the speakers and everybody else behind the scenes for today's production. It's been quite a learning experience. Thank you.